All right, so this video is going to help you with the homework for chapter 3 and give you some hints on this chapter on a couple of the problems that you have for homework. So the first thing that I want to make sure that we know is how to use a very special function in Excel that's going to help you sort the data. So for example, in the first question, it gives you here, it's in 316. When they give us the data, they do not give it to us in numerical order. So they give us just the data, maybe as it was recorded, but it's not sorted in any way. Now, to find the mean, that doesn't really matter. Okay, the mean order doesn't matter. I could find the mean, okay, by just adding up all the pieces and dividing by n. And the symbol for that is going to be this summation e, okay, that we will use. But just adding them all up and dividing by n. And in this problem here, there are, let me double check, yeah, 20, n equals 20. Okay. And so you can actually do this also in Excel. If you have an 83, 84, an Inspire, there's different programming that you can do. You can put this in lists and spreadsheets, or you can put this in the list function and then do some data and statistics on it. In Excel, if you kind of click over to the side, you can do the command average and then open parentheses, and then select the data set, all 20 cells, which will be like A1 to A20, and press enter, and it will find the mean for you. Another thing in Excel that I just want to make sure that you know, because your 83, 84, Inspire, whatever you use for your calculator won't do this, is it will sort the data for you. So if you take like your mouse, okay, and you highlight all 20 cells, okay, all 20 of them like that, just highlight, bloop, they'll be like a gray, not a yellow, but you get the idea. And then if you right click and go to sort, okay, you can sort smallest to largest. And when you do that, okay, what it does is then it says like, oh, well, your minimum value is 35, and then 38, 39, 40, and da-da-da-da-da-da, all the way down. And then on purpose, I'm going to do the last 4. Okay, but not give you quite all of the answers here for your homework, just kind of help you with a couple things. Okay, so it will resort that 20 into this list from smallest to largest. Now, where that's going to be really, really helpful is when you need to find the median, right? So if I have 20 data points, the median splits the data in half, 10 and 10. So then I can look on my list where the first 10 digits are, it cuts off at 57. And then the next 10 digits, and that starts at 58. And so to find the median, it's the number in between 57 and 58. And you can either average that or you just know what that is. Okay, one of the other calculations this problem wants you to find is the mode, which is the most number. So are there any repeats, and which one repeats the most? And then part B of this problem wants you to find the trimmed mean at 15%. Now, what the trimmed mean does is it gets rid of the outside data, just in case there's any extreme outliers. For example, if this instead of 77 was 100, okay, what that 100 would do to the average is it would pull it up to that 100. So kind of the mean here gets kind of pulled around by large numbers or extreme values, where the median is going to be halfway no matter what. And so the trimmed mean gets rid of your smallest numbers and your biggest numbers so that you're looking more at the center part of the data. So how we're going to do that is we're going to say, okay, well, what's 15% of 20? And I calculate that, and that's 3. And so you take 3 data points on either side. Okay, and again, if this is Excel, you can just delete those out and recalculate the average, and that's nicer. Or you can just retype them in, and then you can find the trimmed mean that way. And then 318 is the exact same type of problem here, so you can go in and you can practice that. All right, the next problem that I want us to look at in this video is in that next section, so 3.34. So on 3.34, it's all 20 employees of a small company. So again, N is 20. And again, in this data set, when they give it to us, I'll show you this here. Okay, in the data set, when they give it to us, they don't give it to us in order. So the first thing that I did is I put that in Excel and had it rearrange smallest to biggest for me. Okay. One of the reasons that I did that is because when I go to calculate the range, I need to do max minus min. Okay, and so I need to be able to figure out what's the biggest value, what's the smallest value. And so taking 20, 30 seconds, plugging that in to the Excel or plugging it into the calculator and doing a summary, max and min, okay? One of the things it does not want us to find in this data set, but I want us to find, because it's going to be useful in part B anyway, is I think it would be best for you to find the mean. Okay, and the reason being is to understand variance, you have to understand what the mean is. And so for this data set, I'm going to list out just a couple of these numbers, and they're not going to be in order, but that's okay. They're going to be in the order that they are in the book. So 23, 9, 12, 21, 24. Okay, and so on and so forth. All the way down. There's 20 people, all the way down to 38 at the end. Okay. And so what the variance is going to measure, we're going to call it sigma squared, is the distance from the average. And the question that we're going to be asking is how spread out is this data from the center? Okay, you might have one data set that from the mean has a very little spread. Okay, your mean's here in the middle. You might have another data set that it's very spread. Okay, and so you need to be able to have measures of spread to completely understand a data set, because the measure of center isn't enough. Okay, we need a little bit more. Now, one thing that you could do to figure out the distance from the average is to take 23 and then just subtract the mean. 9 and subtract the mean. That would calculate the distance from the average, okay? And then if we wanted to figure out, well, how far is all of them from the average, and you add them all up, you could do that. What ends up happening, though, is if your data is pretty evenly spread out on the mean, you get something pretty close to 0, which means your data has no spread or no variation. And that would only happen if every single data point was exactly the same, okay? all of these data points are not exactly the same, so we can't say that the spread is nothing, okay? And so what we're actually going to do is you're going to square those distances and then add them up. And that's going to give you the variance. Now, the reason that we square them is twofold. One, it doesn't matter if a data point is this far from the mean on the left or this far from the mean on the right, it's still the same distance to the mean, okay? So squaring it makes sure that these distances are positive, always, okay? Also, squaring it makes extreme data points, okay? Points that are really, really far away from the mean have more weight in this equation, so that way when we have a larger spread, it's calculated by squaring those really large distances and having those outside pieces have more weight, okay? For example, if you had a histogram, let's say, that looked like this, compared to a histogram that looked like this. Okay. The range would actually be, assuming that the number lines and everything are the same, the range would actually be very similar on these. And the means would be very similar, right? Center, range. Center, range. But because there are more data points further from the center, okay, this is going to vary more. Okay, so the standard deviation of this one needs to be bigger because these extreme values, the values that are further away from the mean, need to carry more weight because there are more data points away from the middle versus here, all the weight is in the middle here. Okay, and so that's why our variance equation, and it gives it in the book, I think a little bit funny because then it like kind of splits it up. But data wise or equation wise, usually how we say variance is you take each data value, you subtract out the mean, you square it, and then you divide by n. Okay, and then you're going to add all of those up there. So like the first one, 23 minus whatever the mean is, squared plus, okay, all over n. Now, if you're using Excel, you can have your calculator do this. If you're using a calculator, you can have your calculator do this for you. But it is important to understand where these equations are coming from to understand what they're even measuring. And then your standard deviation is just the square root of the variance. Okay. The last thing they want you to find in this question is called the coefficient of variance. And the equation that you're going to use for that is you're going to take the standard deviation and you're going to divide that by the mean. And it just wants you to find this ratio relative to the mean, how spread out is the data. And you'll multiply that by 100 to find the coefficient of variance here. There is a part C to this question. I gave you a big hint by saying it's all the employees. So hopefully you are able to use that to answer part C. All right, on the next question here, we're going to look at problem 3.48. So in this problem, it gives you some values in a table, and then it gives you a frequency of those values. The problem with data sets, this is very, very common for data sets to be given in this way, okay? The problem is though, is I don't know what values those 17 data points have. They might be 17 zeros, right? It might be 17/4. Or it's probably some combination of something in between, but I don't really know what it is. So in order to kind of weight this appropriately, the way that we do that is we find the median. So the median here would be 2, the middle between 0 and 4. The median here would be 6, and the median here would be 10. You're then going to weight this frequency appropriately by doing the median times the frequency. Okay, so you're going to go through and you're going to multiply these out. So like 34, 138, and then you're going to want to find the sum here. You're going to want to add these up because that's going to be one of the equations that we talk about. Okay. The other calculation in order to help you find variance is to square the median and multiply by the frequency. The book does give you some like rationale as to where that equation comes from, but it's just kind of part of what we do when we do this. So this would be like 4 times 17 because you're going to square m and then multiply by the frequency to get these numbers here. And so here's a couple of those values if you want to check your work and make sure. And then again, you're going to want to add these up to find the sum. And then in the text, it gives us 3 really important equations. So it tells us that in order to find the mean, okay, you're going to take the sum of the MF column, okay, which is this right here. And then you're going to divide that by n. Now, n is the sum of the frequency column, okay? So that's what you'll do to find the mean, okay? And again, it's a weighted mean because there's 17 data points in here, but I don't know where they are. Let's think about this. I'm going to do one more example just to try to explain this just a little even better, hopefully, okay? If you think about this like a histogram, right? This box would have a width or a height, of 17 and a width of 4. But I don't really know where those data points are. I just know there's 17 in there. And so I just say like, okay, well, 2 times 17, okay, is going to give me my weighted piece here. And then like 23 and so on and so forth, okay? Because if you do 0 times 17, it's too small. 4 times 17 is too big, so you just take the middle and multiply them together. All right, for variance, the equation that they give us is they say to use this sum here of the m squareds times f minus this sum here over n, and then you're going to divide this by what's called the degrees of freedom. I don't think it tells you that in the book. I'm not sure, but you divide that by n minus 1. Okay, and then the standard deviation is the square root of the variance. And that should help you piece together how to work problems on 348 and 350. Again, it's very common that we get frequency tables. We don't have the exact data, and so you still need to be able to find the means and standard deviations even when you don't have the exact data points. And this is the way in which you would do that, okay, if you just had the frequency diagrams. All right, in the next section, there's a theorem and a table that I want to show you in the book. Here, and it's about how much data is that far away from the mean, okay? And so on 3.60, it tells us that the mean of the distribution is 220 and the standard deviation is 20, and it wants to know what percent of the data is between 180, and 260. Okay, well, if you think about this on a number line, here's 220, here's 180, here's 260. Both of those values are about 40 units away from the middle. Well, if we take 40 and we divide by the standard deviation, we get 2. And so these are 2, the book calls them K's, away from the middle on each side. And then if you use the table in the book, oh my goodness, sorry. Okay, if you use the table in the book, you go to where K is equal to 2. Okay, 75% right here. So 75% of the data set is between those two values there. Now this is different than problem 3.64 because 3.64 tells you that you're going to follow the empirical rule. And so if you follow the empirical rule, you have a nice bell-shaped curve. Okay, the mean is 180. Okay, and then our standard deviation is 30. So if I think about kind of the same-ish concept, but if I think about like one standard deviation away or down is 150, 2 down would be 120, up here would be 210, and here would be 240. You can use this to help you find the answers to this question that it has in 364. So like on the first question, it says what percent is between 150 and 210. And so that would be 1 standard deviation away. Okay, 30, 30. 30 divided by 30 gives me 1. Okay, and so you can look on the chart there and find your answer for that one. All right, let's look at problem 3.70. All right, so on problem 3.70, one thing that you're going to want to look at on this question is a reordering of this data. N is 20 in this data set. So if I think about each half would have 10 pieces. And so that would give me to the median, but this problem actually wants us to go even further. It wants us to start talking about quartiles. So if I think about how much would be in each quarter, 5 data points would be in each quarter. Now each quarter has its own spread. So for example, you could have a median here and then have 1 quarter here, but then have like a little min, okay? And then you could have like a 3rd quarter here, and then your max might be like all the way over here, okay? So within each quarter of the data, you can have your own spread, okay? Which is gonna come up when you look at box plots, or box and whisker plots. Okay, so once we organize this data, we're gonna be able to find out the quartiles. So if you have access to Excel, that's gonna be the easiest way to sort this data. But like the first 5, once you sort it, 427, 441, 530, 595, and 699. And then the next 5, 716, 872. So again, I'm just finding how many data points are in each one, sorting these minimum to maximum, and figuring out which data points are within each quartile. Now, the reason that I'm going to do that is it wants me to figure out where Q1 is. Well, Q1 is going to be whatever the middle point is between 699 and 719. So Q1 is the middle point of 699 and 716. Q2, which is the same thing as the median, will be whatever the middle is between this number and the number that's here, okay? And then Q3 and so on and so forth. And then it also wants you to find the interquartile range, which is Q3 minus Q1. On part B of the question, it wants you to start thinking about percentiles of the data. So it says what percentage, or what approximate value, sorry, is at the 57th percentile. Well, I know it's going to be a little bit bigger than the 50th percentile, so it has to be somewhere kind of maybe in that line right there. And the book says what you're going to do is you're going to take n times 57 over 100, and that ends up giving us 11.4. So I want to always go to the next term. Okay, always go to the next term. Don't round, go to the next term. So then if you have everything in a list, you can go to the 12th term and you're done. Okay. Now, if I wanted to find the percentile rank of a certain thing, okay, percentile rank of 1046 here, then what you're going to do is you're going to take like that number, like what's the rank out of 20, and then multiply that by 100%, and that's going to give you the percentile ranking for that number. All right, last question that we're going to go over in this video is going to be 3.76, which is box plots. And when we do box plots, you're going to use the 5-number summary. In order to do that, you're going to use the quartiles to do that. So again, I'm going to take that data set that they give me here, and I'm going to put it in Excel. And n equals 20. And again, if you don't have access to Excel, and you're like, she keeps saying to use Excel and I don't have access to that, you can use your calculator if you have one, do a dot plot and then just calculate it from there. Or you can just go through the data. It's going to take a little bit of time, but you can go through the data and just order it that way. And so we get 3, so again, it's 20. So it has the same breakdowns here, but we get 3, 5, 5, 6, 8, 10, 14, all the way down to our max is 34. All right, so I know my first quartile has to have 10, or it has to have 5. Sorry, here, let's do this. 10 in each half, 5 in each quarter. Okay, so I'm going to go 1, 2, 3, 4, 5. These are the data points in my first quartile, and Q1 has to be the midpoint between 8 and 10, which is 9. You're going to find the median. You're going to find Q3. Now, here is the thing that students do a lot. Usually what students do incorrectly is they're just like draw some like arbitrary box plot and then just label it and be like, there you go. Okay, but the whole point of a box and whisker plot is you're able to see shape really well and skewness really, really well. So the first thing that you should always do is draw your number line first and fit your data to the number line. Okay, draw your number line first, fit your data to the number line. So I need my values to go from 0, 5, 10, 15, 20, 25, 30, 35, and then you'll draw your box and whisker plot there. That allows the shape to be correct. So we'll have 9, okay, you'll fill out the rest of your box, and then remember your whisker goes down to your minimum and then up to your maximum here at 34. Okay, but I don't want to do the whole problem for you, so I'm not going to do any more of that question. But I hope that you found these hints really helpful. This homework is a lot more calculator and equation heavy than the other two. So if you have questions about what equation you should be using, the book is very helpful in like outlining those equations for you. So make sure you reference that.